Good afternoon, Sevens. So I wanted to talk through some of the things I was hoping you'd see this morning and you'd gain a new sense of this new metric that we actually need. We have really quality ways to describe center, but we don't have great ways yet to describe spread. So we're just trying to, I'm trying to create the need that you'd say like, we need to describe this spread stuff better. In order to do that, we've all seen diagrams like this recently. There are three ways we can typically talk about data, and I should have added shape is also important. But both of these data distributions have the same shape, so it's not something I have to worry about in this case because the gray curve and the green curve are both bell curves or normal distributions. So they have the same shape. I'm not going to consider that. But their centers are very different. So, we've all seen graphics with this saying this would have been the number of cases of COVID if we didn't social distance, and then the healthcare system capacity is a problem because like all of these people don't get treated basically. And this is what occurred in Italy and in some other localized places. But as we've socially distanced, we've pulled over more time, we've pulled these cases out. So the same number of people over time will get sick, but it'll take longer for those people to get sick, which means over that amount of time we stay below where our healthcare system can care for them. That said, the center of the gray curve is near here. I know that line's not perfect. And the center of the green curve is near over here. So you'd see the center of the green curve is way more to the right. It's just saying that the cases happened faster in the gray curve. Okay, well, spread has a different type of metric. The way we usually think of spread is we look at a certain percentage of the data. So I could say like maybe about 60% of this data in the gray curve is inside of that, like those values there. So like between here and here on the gray curve, we'd have about 60% of the data, like the vast majority, right? But it's very different on this green curve. Things are more spread out, and now this is gonna get really, really messy. But you can see our curve here, like within that, we have a ton of data values because this is a really, really high curve. Well, this is a much lower curve. So to get down to like this point, for example, I have to go down a lot further. Maybe it's spread out to here. So if we were looking at that spread metric, you'd see the spread here is relatively small, spread here is relatively large, just saying that the data is more spread out. So here's some examples. We have 4 curves here. I've got dark blue, we've got light blue, we've got green, and we've got a red bell curve. Again, shape is taken out. All of these have the same shape. So we're only talking about center and spread. I've said 3 of the 3 graphs, that's misstated. 3 of the 4 graphs have roughly the same center, but none of them have the same spread. So which colors of graphs have the same center? Well, when you look here, I bet you can tell 3 of those curves have the same center and the 4th one doesn't. I'm trying to give you enough time to think. When I look at that now, I would see like, here's the center of the light blue curve, but the dark blue curve has a center here and the green has a center here, and so does the red. So to answer that, I would say here, which colors have the same center? Dark blue, green, and red. Then the last question, list the colors of the graphs in order from least spread to most spread. So least spread we could say is the most consistent. It's the closest to the center all the time. When I look here, which one is spread the least or is the closest to the center? It's definitely the red. It's the narrowest, which means it's the least spread out. So least spread out would be red. Next one I can see is light blue. Next one is green. And the last one is dark blue. But you can see what I'm looking at when I look at that, the least spread to most spread, what I'm thinking is like, we've got a center here, but how spread out is this stuff? Well, we've got a center here, but how spread out is this stuff? Well, this one is the most spread out. This one's the least spread out, and I think it's easy to see the rest. So let's look at things you were looking at this morning. I want to talk first about how can we argue that the bike is the best mode of transport for James. Well, I had clued you guys off to, I think these are the most useful indicators to talk about this: mean, median, range, and outliers. So I've got the mean, median, range, and outliers for all of them, and I did dot plots for each of them too, because I want to make points of this. So when I compare the means, I can see biking and taking the train both have a mean of 26, which is good. Biking has a median of 25.5, and taking the train has a median of 25. So just saying, if I only use measures of center, taking the train looks the best for sure. Like that would be the one based on measures of center alone. But when I look at other things, I think I can really make a quality argument for the bike. The reason is the center is like here for the bike, and all of this stuff is pretty close, just saying that the range is small. Whereas for the train, our center is here, and then this stuff is more spread out. Like sometimes it takes 31 minutes, but it never takes more than 30 minutes biking, which makes sense. So that's just to say the bike doesn't necessarily have the best center. Like the centers are the lowest for the train, but the bike is the least spread. So I would have argued this first one, the bike, the bike is James's best mode of transport. I would have argued because while the bike and train have similar centers, the bike has the least spread, meaning his commute will be the most consistently near the mean. So the range being small shows us that our data is generally closer to the mean. Now it's harder to argue for the car. So let's go ahead and look at the car. Here's what my argument for the car. When I look at these, I see like the car has the worst measures of center. It has the worst range, like it's really spread out. But the reason comes down to the fact that there's this outlier at 57 minutes. So one thing statisticians sometimes do, and this isn't always a dangerous thing to do, but it's pretty common, is statisticians will throw out the outlier. Here, I've just thrown that data out, and I've recalculated our mean and range based on only the data values that are clustered, not the outlier. And when I do that, I get a mean of 25 and a range of 13. Well, that's interesting because now when I compare these means, I can see that is the fastest. So my argument for the car would have been there was one day that James drove with exceptional circumstances, probably traffic. If we throw out that outlier and recalculate calculate the data descriptors, then the car has the lowest average. That would be my argument. Now, honestly, I don't believe this argument. When I look at the data here, I see that the bike not only has like a relatively similar average, it has the smallest range. That to me is the strongest argument in this case. But this is an argument, and it definitely shows how we can use the data to support this argument, because it does have the lowest average. Like, it just has more variation, and I can see that because the range is still 13. Even if I throw out that outlier, well, the range biking is 6. That to me is better. But all of this comes back to the fact that measures of spread are super useful. Like looking at values that are really clustered together versus values that are spread out, we need better metrics to describe that idea. Right now, the only metric we have for spread is range. So we need a better metric, and we will get one soon. That is all I have to say for right now. You guys have a follow-up activity. Oh, that's Math 6. Your follow-up activity, follows a similar idea. The difference now is I'm going to give you the descriptions of things, and you need to try to create data that matches that. Now note that your data for the bicycle times or the car times here are not ordered. They're not, there's nothing done for you. You have to be able to take this information and break it down to see this. And I'd just say that some of this is obvious, like the range of bicycle times is 6 minutes. Well, I don't need to tell you that. We could compute that. You'd see 28 is the highest, 22 is the lowest, range is 6 minutes. But a lot of this information is important, and you will need it in order to create car data that matches the same. As a last note, if you blow through this and you think it's way too easy, send me a message right away, because I have 2 data sets that actually are more difficult than these. It's a similar activity, just kind of a challenge level. And if these are too easy, I can get that to you. But I'm willing to bet these will take some time. They're difficult for most people. So best of luck, Sevens. I'll talk to you soon. Bye-bye.